Hi and welcome to another video in the RHCSA video series. Today's video is on Configure IPv4 and IPv6 addresses. So firstly, let's discuss what IPv4 and IPv6 are. So this is essentially the section is on IP addressing, and an internet protocol or IP address is an individual address for a host on a network. So when you're using the internet, your IP address is assigned to you by your internet service provider, for example. So when you then use your device within your home network, you're going to be assigned a local IP address by your router, and then the router will use a network address translation to, or NAT, to translate your local address to your ISP provided address. So you'll then have basically a public IP address, which is you can use then to route to the internet, and you also have a private IP address, which you use within your home network. And that's common as well across businesses as well. So I have a public range of IPs they use, or a single IP potentially, and then they'll have hundreds, maybe thousands, or even millions of private IPs that they use NAT to then get out to the internet. So there are two types of IP addresses in use. There's IPv4, which is obviously IP version 4, and that's the most widely used version at the moment. Most websites still use IPv4, and most networks around seem to still use IPv4. IPv6 is a more modern iteration of the internet protocol, but as always, it's because it's so widely used. It's a mammoth task to uplift everyone to use IPv6. So that will happen sometime in the future. So you have to kind of cover both at the moment. So I've just popped in the screen a bit more information about IPv4, so I'll just be covering that first. So there's the IP addressing in IPv4 is a 32-bit address, and by bit I mean ones or zeros, as in normal computing, and uses decimal numbers. So you just got numbers 1 to 10, and it's in 4 octets. So you have 8 bits in each section. So 8 times 4 is 32. So you get the 8 bits in each section. So you can have up to 255 as a value. So your IP address, for example, as an example here, is 172.16.254.1. That's a perfectly valid IP address. And with IPv4, there was something called a class system. So you've got the different classes, and I'll just put it on here at the moment. The example I just gave you there is a class B example address. And you can see the different network intents of those different IP addresses. There's also a private class system as well for the IPv4, but again, this is kind of a legacy thing. You may have people that mention class A, B, and C internet IP addresses for IPv4, but it's not as widely used nowadays. So the more modern way we're using now, for instead of having classes for IP addresses, we're using CIDR, which is classless inter-domain routing. So that uses your thing called a subnet mask, which is what we use anyway in IPv4, and that allows you to express the subnet mask in a short form. So with regards to a subnet mask, I'll just go and put that on the screen. A subnet mask is like it's a block on particular areas. So like, say again you have this IP address of 172.16.254.1. You could have a subnet mask of 255.255.255.0, and that limits the network to be 172.16.254.1 to 255. So you can have any number in between, because you've got the 255 blocking that first octet, 255 blocking the second octet, and 255 blocking the third octet. That's completely unusable essentially. And then you've got the final one, which is 0, so it's completely open to have whatever you want in there. So you could have you can be quite flexible with subnet mask. You can have it quite large and you can have it quite small. Obviously for home networks and stuff like that, it's probably most likely to be 255, 255, 2550. and then you can have up to 254 usable addresses. There's another thing to mention. There is a thing called a gateway, and this is just your router on your network. So your gateway might be on .1 or .254 maybe in most networks, and that is just to get to other networks. So if you, for example, again, your home network, you try to get to the internet, you'll contact your router, which will be on .1 for this example. Then this router will know the next hop, which will be the next router it needs to talk to get to the next router, and eventually you get to the website or whatever you're trying to visit. So the good thing is we've got all these things of gateway, subnet mask, and CIDR. These all transfer completely across to IPv6, so they're essentially the same. The only difference is with IPv6, you've got a much larger address space. So I'll just talk quickly about IPv6, and then we'll go on to actually do the configuration of both of these on a new network card on the server. I'll just cover these to make sure it's fully understood what we're actually doing. So IPv6 is 128 bits, so it's much larger. You can imagine much more larger, and it obviously compared to the 32-bit on IPv4, and it also uses hexadecimal numbers. So that's the one numbers 0 through to 9, and then A through to F. So that gives you obviously more information it can store inside the smaller IP address. The reason why they created IPv6 is one of the main reasons was we were just running out of IPv4 addresses. In fact, there's like crazy auctions nowadays for IP address spaces, and people purchase spaces and then utilize those for the internet. IPv6 are classless, so there's no class A, B, or C like there is in IPv4. That's quite good. And you use prefixes which are the same as CIDR on IPv4, which allow you to then work out the subnet values for those particular networks. It uses the same gateways, IDO, stuff like that, and it's just a more modern iteration. It looks more difficult to read, but to be honest, it's all pretty much the same thing. It's just the numbers. It uses numbers and letters in the IP addressing. It's not that much different. So you may have the gateway as so you may have the IP as 2006 dot colon AC81 colon, which is a shorthand 1105. That could be your IP address, and your gateway could be 1101. So it's not too different from IPv4 really, and in practice it really isn't that different. It's just a very big address space. So yeah, you just got to be careful with IPv6. If you sign a too big network, you can end up with millions, even billions of IP addresses available to you, even on the most tiniest of networks. So it's very flexible in that way. You can give, I think they can give, it's like maybe hundreds of millions, no, maybe just millions of addresses to everyone in the world, and we'd still have some spare. So it's got plenty of IP addresses available for IPv6. I don't think we're going to run out of that anytime soon. Okay, to actually configure them, it's pretty simple. So the first thing I'd recommend is, let me just shut down this server, and we'll go to the actual console, and we'll create another network card because I don't want to break my existing connection. So we just go to settings on the virtual machine, go to network, go to adapter 2, enable network adapter, attach to, it doesn't really matter, we can just do a host only adapter, so it can only talk to itself. That's fine, just leave the defaults, it literally doesn't matter. Click OK, and then we can start the machine back up again. Right, my machine's back up now. So just one note, I appreciate there's a lot to learn if you haven't learned it already, the IPv4 and IPv6 stuff. So also check out my blog. You can read a bit further on that, and I've covered it in a bit more detail on there. So yeah, please check it out as well there. Hopefully that will be helpful to you. So as always, go to the terminal. Let's sudo. Cool. Okay, so everything for the network management is managed by the Network Management CLI or nmcli, and we can do first connection show. So it'll show all the connections we currently got. So we can see we've got a wide connection 1, and this is UUID, you know, universal unique ID. It's type Ethernet, and device is that. Let me just do an IP address to get a bit more information about the networks to make sure I don't disable the one I'm using. So the one I've got active is the 10.network, so that with that one. So this is the new one that's just created, which makes sense because 1, 2, and 3. This is the third one. So this P0S8, which is this device here. Okay, cool. That connection show gives us information about those, and you can see it's green, so it means it reckons it's connected. Okay, so we can then do a nmcli device status. And it'll give us the status of those, and you can see it's connected, hence the green writing as well. We can then do nmcli device show, and that will give us a lot more information about each device. So the one we care about is this ENPS8, and yeah, you got the MAC address, you got the MTU, state, etc. Yeah, you can see all the information, IP address, and all that gumph is all there, which is quite useful. It's quite a nice output. Just do a clear. Right, so for the sakes of this, I'm going to delete this interface. So let's do a connection delete ENP0S8. What was the, did I get it right? Let me just check. Oh, it's called wide connection in this case. Wide connection 1. You don't want to delete your active network card, so please be very careful when you do this. Okay, so then we can just double check it's gone. So we can do nmcli connection show, and it's gone. Great. So let's add the connection back, and we can give it a nice name. So let's do a clear again. So nmcli connection, add connection name is, let's just give it ETH0 or Ethernet 0. Interface name, this is the actual interface itself, so it's EMPS8. Type will be Ethernet, it's an Ethernet network, and we want to give it an IPv4 address from the start. So let's do that. IP4 10.02, let's do 16, doesn't matter, 24, so that's the CIDR address. So that's the shorthand for /24. In this case is 255.255.255.0. There is actually, you can look it up on the internet. It's not something that's just simply to just understand by looking at the maths or whatever. It's just a shorthand, so you have to just kind of just learn it, unfortunately. So after a while it just becomes second nature looking at these. Let's set the gateway or the next hop router, and in this case let's just do 2.1. It literally doesn't matter for the sake of this test. Press return, and we've successfully added a connection. We can then do nmcli connection show, and we can see it's green, so it's probably connected. Let's do an IP address, and we can see ENPS8, and it's got an init address of that, and you can see it's up. That's good. Let's multicast up, lower up, let's broadcast up, so it's all good. Again, we can also do an nmcli device show and then EMPS8, and we can see it's connected, it's MTU, all that sort of stuff. Destinations, you can see the network here is there, and if it's in this network, it'll be on this interface. If it doesn't know it, will go via the gateway here, as you can see. Okay, so if we want to bring the connection up or down, we can do an nmcli connection up, for example, ETH0, successfully activated. We can do a down, and that's deactivated, and obviously that will reflect if we do nmcli connection status Oops. Show, sorry. Apologies. And you can see it's now disconnected in that case. So just bring it back up and then just do a show again, and we can see it's back up. Cool. Pretty simple. To manually reconfigure an interface, we can just do an nmcli connection modify, and then we can do the interface IPv4 dot address, and then we can do again another address potentially 2 dot, let's do 16 in this case. Let's do 15. It literally doesn't matter. Slash 24, and press return, and then we're going to do IPv4 dot gateway, and then 10.02.1 24. What did I do wrong? 02. I don't need slash 24, sorry. And then we need the nmcli connection modify eth0 IPv4 dot method manual. So this last line, method manual, means I don't want to use DHCP. So in most networks, especially the larger ones, and probably a home network as well, it uses DHCP, which is a dynamic host configuration protocol. This allows you to automatically gain an IP address from a DHCP server. So in most cases your DHCP server will be your router itself, but obviously in larger networks you have a dedicated DHCP server. In this case you're just saying, I manually configured my IP address, please do not try and go and get an address from DHCP server. That's literally it. So shall we check that's applied? So that's dot 15. I think we have to bring it the interface up and then down to then apply the change. So let's do that. Let's do down and then up, and that should get the new IP address. Yes, so it's now to update the IP address. So you've got to do a down and an up to get the change. So obviously while we did the modification, it doesn't actually reread that information until you reset the adapter. So I just did a down up and it's actually updated that. Okay, so let's do the same for IPv6. So the concept is exactly the same essentially. The only difference is the IP looks a little bit different, that's all. So let's do nmcli again. Let's delete that connection actually. So connection delete, and then eth0. That's gone. Okay, cool. So we do a new one. Let's do a clear, and let's do nmcli connection add connection name. Oops, con name is eth0 again. Interface name is enps8. Type equals Ethernet IP6, and then we're going to set the IPv6 address. I just grabbed an example from the internet. It literally doesn't matter. Okay. And then set the gateway. So gateway 6 is 206. We can do AC 811101. Okay. So this address, it looks relatively short, but actually it's way longer than this, but we're just we're doing a bit of shorthand here. So 2006, that's pretty much, yeah, that's an octet essentially for this IPv6 address. And then you've got another one here, and then you've got short to say all in between here is just zeros, and then you've got this, which is the final part of the IP address. In this case 1105 is the address. And then you've got the gateway, which is the same network, and then the final bit is just 1101. So that's the first address in that particular network. And it's successfully added. And then we can do nmcli connection show. You can see it's connected. We can do an IP address. And you should see it in here. So inet 6 or internet address 6, the IPv6, sorry, and you can see it's there. Awesome. So again, you can do all the same things, you know, it's device so, etc. But it's, you know, it's all the very same. There's not really much to discuss there. Okay, so we can also do the same thing. We could do a modify, so we can do nmcli, we can do connection modify, and we can do eth0, and we can do IPv6 dot address. Okay, IPv6 address, and then do AC81. Let's do it again. 1106/64. And so /64 is a very, very, very big network, but just for example, it doesn't really matter too much. Let's do the gateway, IPv6 dot gateway 2006 AC81 ::11 let's say 1101, leave it like that. Okay, and then we can do again nmcli connection modify eth0 IPv6 method equals a manual. And if you, I don't know if you've noticed, I don't know if you noticed, but they're actually in a form called tool stack. You can see it's actually got IPv6 and IPv4 at the same time. So yeah, it's got, there's the IPv4 address, and it's actually picked up a DHCP there's the IPv6 address, and this is the IPv4 address. It's picked up by automatically this dynamic address. So that is a very quick whistle-stop tour on how to configure IP addressing. As you can see, it's relatively simple. The nmcli is really pretty powerful. As always, there's a man page. nmcli will give you a great output and good something to read about that. And obviously there's the info page. I'd imagine there's one for this as well. Yep. So you got a man info if you need to pull for context for the commands. Also check out my blog for more information about IP addressing. The link is in the description below. So yeah, as always, I've put the usual information on there. So my Ko-fi page, if you want to drop in donations, that would be absolutely fantastic. Also got my merchandise page, if there's something you're interested in, that'd be awesome too. Yeah, just thanks again for checking out my videos. They're really appreciated. Like and subscribe if you haven't already. Yeah, thanks again for watching. I'll catch you next video. Thank you.